button. All right, so for your warm up here, I'm gonna put our type B person here on the top. You might have put yours on the side, and that's okay. As long as you include the uppercase I and the two B's superscript. And then I'm gonna put my type A parent over here. And then remember the rule I told you yesterday is always write the A before the B. So if you have, in this case, an A and a B, because we call it type AB blood, so we write it as AB. And then if there's a dominant and a recessive, you always write the dominant allele first, as in those two bottom boxes. And like I said, you might have put your parents on different sides. That's okay. All right, so then once you've filled in the Punnett square, you can answer some questions. So what percent of the offspring are going to be type AB blood? What did you guys write? 50%. So these two out of 4 is 50%. All right, what percent will have type B? Also 50%, right? Because these two will be type B. I just want to remind you to please read carefully what the question is asking, because I think sometimes we make little mistakes when we don't read fully what the question is asking, and that's just a good test taking skill. So like if I asked you what percent of the offspring would be type O, that would be 0%, because none of the babies, if you remember from yesterday, type O blood has the genotype i. The two homozygous recessive is type O. All right, let's move on to our X-linked example here. That's another thing we talked about yesterday, was how our X-linked recessive traits passed on. So we're gonna imagine a father is unaffected by color blindness. And remember, color blindness is an X-linked recessive trait. So if he's unaffected by color blindness, what is his genotype? I'm going to use B's for color blindness. You can use an A if you want. And then what's his other letter, or what his other, he has to have a Y, right? And again, the Y does not get a superscript because these genes do not lie on the Y chromosome. The Y has no X-linked traits. So you don't ever put a superscript on a Y. All right, and then mom is a carrier for color blindness. So remember, because females have 2 X's, if she's a carrier, she's normal sighted, meaning she has a big B, but she's carrying the little recessive allele that she could pass on to her sons or her daughters. So it's just, we call that a carrier. I know we've been calling it heterozygous, but in this case, we call her a carrier because she doesn't show the trait, but she carries the allele. All right, so this Punnett square has sperm and eggs on it, so we can put dad's gametes in the sperm and mom's gametes in her eggs. And just remember, when we fill in a Punnett square, we're filling in what the baby's genotypes would be, the offspring. So this first daughter is going to be big B, big B. This son is going to be X, big B, Y. And again, we always put the Y second. We don't ever put it in front of the X. And then if there's a dominant and a recessive, like in this box, you always put the dominant before the recessive. That rule is always going to stay the same. And then we have a son here who looks to be carrying the recessive allele on his 1X, which would indicate that he would be then colorblind. All right. What are the chances that these parents will have a daughter with color blindness? So if we look at just, I'm going to say just looking at daughters, that would be 0%, right? None of their daughters are going to be colorblind. Remember, in order for a daughter to get an X-linked trait, dad has to have it. He has to be carrying the recessive allele and have the disorder in order for a daughter to get it. And this dad was normal sighted. How about their sons? Just their sons. That would be 50%, right? Because we got 1 out of 2. What percent of their daughters will probably be carriers?
Oh, not 100.
Not 100, because this daughter right here is not going to carry. She's homozygous. Well, and I understand why you said 25 is because it's 1 square out of 4, but we're asking about just the daughters here. So it would be 50% of their daughters would be carriers. Right? This daughter right here would be a carrier. All right, if a couple has a son who's colorblind, who did he get it from? He got it from mom. How do we know it's mom? How do we know it's not dad? So dad does not give sons X chromosomes, right? So dad gives all of his sons the Y. So if a son has an X-linked disorder, he got it from his mother. All right, if a couple has a daughter who's colorblind, who did she get it from? Yep, so she had to get it, my student in my room said mom and dad, right? Because mom has to give her a little b X, and dad also has to give her 1. So that's why, that's another reason why it's rare for a daughter to have it, because these alleles are rare anyway in the population, but then for a daughter to get it from both parents is rare. So why are X-linked disorders so much more common in men? It only takes 1 X, right? So males only have 1 X. Yep. So they only have 1 X. If they get it, they have the disorder. It can't get like another one and cover it up and mask it like females can. They get 1 shot, right? All right. So again, this is all stuff from yesterday. You had a homework assignment that's due today, homework number 7. If you haven't turned that in yet, today during work time would be a great time to finish that up and turn it in. All right, now we're gonna get to something a little different. But this is something that I really, really love, and I've been actually working on my own family's pedigree for a while here, and I'll show that to you in just a bit. So we're going to start looking at pedigrees. This is what we're going to do next week as well. And what it is a family tree that's organized in a way to show males and females, the order of their birth, and then who's married to who and who has kids to whom and how everybody is connected. So these are important. These are oftentimes these are made if you ever have a genetic disorder and you need to go talk to somebody like a genetic counselor about your risk of passing on a genetic disease. So next week we'll start adding diseases to our pedigrees and looking at how to figure out what kind of pattern it follows, but today we're just going to learn about what a pedigree is. So we're going to start off here with the very, very basics. Okay. So we represent males on a pedigree with a square. We represent females with a circle. Okay. That's the first step to understanding a pedigree. You got to understand that first. And throughout the years, I've asked students like, hey, how are you going to remember that? Because you gotta. And I've had lots and lots of crazy answers. One of my favorites from one of my first years of teaching was my student said, well, females have circles. And I said, well, so do males. And we had a good laugh. And then somebody said, females are more curvy. And I said, okay, now it's getting a little uncomfortable. So anyway, you got to remember that females are circles and the squares are. Oh, someone just said males have 4 letters, 4 sides of the square. Nice. I haven't heard that one yet. That's new. Awesome. All right. So moving on. The next thing is when a male and a female have a line connecting them like this red line, that's called a marriage line. Although it might not mean that they went and got married officially, like they went and got, stood in front of a church in front of their family or a judge and said, I do. It might just mean that they reproduced. So they had a child. Okay. But normally it does mean a marriage. But people I know this is crazy, but people have children without getting married. So sometimes it doesn't mean they're married. All right, moving on. When there's a line going down from the marriage line, this is what leads to a new generation. Okay, so this is how we show a new generation of children are being born to this couple. So we call this a descent line. So it shows the humans that descended from these 2 parents. Okay, and so if a couple has children, they will have a line going down from their connecting marriage line to show their children. Now, the line that goes horizontal that connects to the descent line is called the sibling line. Okay, so any circles or squares that are connected to the sibling line shows siblings born to the original couple. Okay, so we can see what kids this couple has by looking at who's attached to the sibling line. So how many kids then did this original couple have? They have 3, right? 1 son, 2 daughters. 1, 2, 3. Well, I just answered the next question. So this is where you need to make sure you understand the circles and the square part. So they did have 2 daughters, right? The circles are my daughters. And they had 1 son, the square. They have a square son. He's square. Get it? All right. All right, so we also have a way to organize a pedigree, and we do this by labeling each person. So in order to figure out the age of a sibling or a mate, we use location along with numbers. So we label the generations with Roman numerals. So hopefully at some point in your education, you learned what a Roman numeral is. It looks like an I, and then 2 I's is 2, and 3 I's, and then you start adding a V, and V is 5. If you have a 1 in front of the V, it's 4. Anyway, the generations go on the side, on the left side here. You just write them once. So this is the first generation that's being tracked. This is the second, third, fourth generation. So you can see that in the Roman numerals. Then each person inside of that generation has normal Arabic numbers. So the numbers that you're used to seeing. The normal Arabic numbers show the age of the people in each generation. So from left to right goes oldest to youngest. So it's like reading, you go oldest, and as you move to the left, it gets younger, okay? So for instance, 1 and is older, the husband in this case was older than his wife, okay? 1 is older than 1 2.
What is black meaning?
So somebody in my class just asked me why are some of these squares filled in? We're going to talk about that next week. Okay, because this is an example of tracking a genetic disorder, but today we're just focusing on how to read a pedigree. We'll talk about why they're colored in later. All right, so we can answer some questions here. What is the sex of individual 2-2? So we got to find 2 is right here. It's a square. So that is a male. How about 3-3? So we're going to go to generation 3. We're going to count over 1, 2, 3. This is another square. So we have another male. All right. How many children did 2-3 and 2-4 have? So here's 2-3 and 2-4. They have a descent line and 2 siblings right here. There's 2. Son and a daughter. All right. How many children did 2-1 and 2-2 have? Is it 1? Nice. Awesome, Aiden. All right. So sometimes people think that the answer to this question is 2 because there's 2 people here, but because there's only 1 child connected to the descent line, 3-2 is an only child. So they had 1 daughter. 3-1 is somebody she married from outside of the family. So they had 1 child. 3-2 is a female, and they didn't have any sons. So you just got to be careful when you're looking at a pedigree because, like I said, that looks like they had 2 kids, but they didn't. They had 1. And then 3-1 is actually this couple's son-in-law, right? He married their daughter.
Oh, so is that the black?
No, I know you're trying to figure out the black. The black is going to indicate an X-linked disorder. So we'll talk about it later, but so don't worry about it too much right now. All right. So then which child of 3-1 and 3-2 is the oldest? So which child of 3-1, we got to find 3-1 and 3-2 is the oldest. Is it 2? It's going to be, remember, oldest to youngest. So it's not going to be 2, it's going to be 1, 4-1. All right, so what I'd like you to do now is take a moment and draw a pedigree of your family with at least 2 generations, which I mean, so by that I mean your parents and your generation. And I also said if you want to choose a friend's family or a famous family, that's fine. This is not graded. It's just to experience writing out a pedigree. And there are some extra symbols I've added down here. So if you are a twin, you can see that there are I have twins in this class. You can be either a fraternal twin, meaning you're not identical, or a monozygotic twin, which means you're identical. Is what? I think nearsightedness might be if you can see things near, but you can't see things far. I don't know. I'm not sure if that's genetic. Yeah. So, oh, I know, I wanted to point out, like, if you have a mom who's been married to two different men, which is very common, it's totally cool. Then you might have to make, your mom like this, where she has two, like, this would be a husband that she got divorced from. This double line means divorced. So that doesn't mean they didn't have kids, right? They could have had kids. But maybe she had kids with another. So that's how like, if, let's say this is you and your mom has another, so you have like stepbrothers, would they become considered stepbrothers? This person, step siblings?
So should we start at our grandparents?
I'm asking you to start at your own parents.
And do we get just them two or all of their siblings?
You can just start with your parents. You don't have to add all their siblings unless you want to. But like, what I was looking for is just your parents. And, maybe you have other parents or it could get a little crazy, but
So,
my dad was older than my mom. What was that, Mr. Manzan?
so remember when we kind of talked last quarter about that new symbol that isn't on your list, the transgender?
Oh, yeah. Yeah, I was gonna share that too. So
Okay, cool.
transgender, because I was gonna show my pedigree. So if you have a transgender person in your family, this is a transgender female. So the square inside of the circle means they were born male, but they identify as female. So they're a circle, but they have a square within them. And then the other one is the opposite. So it's a square on the outside with a circle in the inside, would be a transgender male. I can spell transgender male.
Okay,
Because you can add them to your pedigree too. If you have a transgender family member, or if you yourself is, that's how you indicate them.
I have a question.
Yeah.
How would I draw if I had a parent, right? And then they're deceased,
Hmm.
and my mom remarried and had another sibling.
Yeah. Yeah. So if you have, I have a student asking about a female who was married before and he's deceased, right? So that's how you would draw him. You put a line through anyone who's dead, and then she remarries, and then, so is this your dad?
Yeah.
So this is Joe.
No, of the deceased.
Oh, you're the child of the deceased. Okay, so you're over here then, Aiden. Did your mom have just you with him? Yep, so this is how you would do it. Did your mom and Joe have kids too?
Yeah.
Okay, so then you would do this. Sorry, I know one of my students' parents. Did they have more than one or just one?
Asking me?
Yeah, they have just one. Okay, so one would be like this. Is it a girl or a boy? Oh, you have his little sister.
Okay, so that's it.
Yeah. All right. I do want to share with you the pedigree that, actually, I'm going to give you guys another few minutes because this is kind of fun to do. So draw your family.
Would there be a line between me and the sister?
No, unless you guys are going to get married.
What other thing when the siblings have a line, but oh.
So we're going to talk about that double line and what it means. But if you guys would not have a line connecting you, you have the same mom, but you aren't connected to the same sibling line because you both have different dads. Yep. I'm sorry that your dad is no longer on with us. So somebody just asked in my class, what is consanguineous? Consanguineous, is that how you say that?
That's Alabama.
That's when you have a mating between two siblings. So I know everyone's giggling. We'll talk about it in just a second. All right.
I got a question.
Yeah.
So, okay, how would I draw this? Because, wait a minute, hush, real quick. So,
Way to make it weird, Klepper.
oh no, I'm gonna make it weird for you, watch this. So, on my dad's side, my dad has a brother that's also his cousin.
Oh. Oh, boy. Okay, it's not that weird. I don't know. I'm just trying to think of how to draw it.
Because that means his dad married his sister.
Let's play that one again. That was a good one. That for that one.
Okay. his
Hey, Josiah, let's work it out during the work time, okay?
So his
All right. So you guys, I'm so glad that people are enjoying this. I have a couple students that I have a little bit of tricky genealogy that we'll have to take a look at. But I want to keep us moving here. And before we leave this, I just wanted to show you a pedigree of my family that I've been working on. So here is my family's pedigree. It goes back to these are my, Joe and Laura here are my grandparents. So this is my grandpa and grandma. And then, so these people up here, Thomas and Marie, are my great grandparents. And the reason that I've made this pedigree is because I'm tracking a genetic disorder through my family that I found out that I had in 2019. So here is my grandma and grandpa, right? So this is my dad right here, Ron. So this is my little family here. So I have an older brother, Ron, who has autism, so he's not married. My older sister, Peg, is right here. This is my brother, Joe. Here I am. I'm married to Kevin, and we have no kids. So this is how you draw no children. And then this is my younger sister, Mary, and her husband, Peter. They also don't have children. My brother, Joe, and his wife have 3 daughters. 14, 10, and 8, I think. And then my older sister, Peg, has 2 children. Jackson is their firstborn son, and then Ren is their transgender daughter. So this is transgender girl. So born Jonas and now identifies as Ren.
Okay.
So that's how you draw it.
It goes the other way around.
Yeah. Yep. Okay, so I just wanted to point out one thing to you. So I'm tracking a genetic disorder through my family, and I'm trying to get my Uncle Tom right here to get tested for it, because look at all of his descendants. He has 15 descendants that could potentially have the genetic disorder that I've been tracking. The disorder is BRCA2. Oops, I did not want to do that. A BRCA2 mutation that leads to breast cancer. Yeah, and I found out because I had breast cancer 2 years ago. Yeah. Yep. All right. Okay, so I do want, before I move on, I just also wanted to show you my cousin Chris here has 3 baby mamas. So this is how you would write that. Yep, I know. So 3. So he was married to Kelly, and he had my cousin Nicole, and then Nicole married Andy and had kids. Then he had a baby with Jolene, so Kane was born. And then he had another baby, Bobby Joe, with Eileen. So this is how you draw if you have a person who has multiple mates. You have to make connections to all of them. What's that? Yeah, he's a special person. All right, so that's my family's pedigree, and I did this. I can explain it a little bit later when we get to how to track genetic disorders, but I made this for my family to try to convince my Uncle Tom to get tested for a genetic disorder. All right, so let's take a look at and make sure we understand how to read a pedigree, because your homework tonight is, can you read a pedigree and tell who's who and relationships? So yep, so don't look at this yet, okay? Don't look at this yet. Just keep your eyes up here. Let's focus on this pedigree. I know you're excited. My class is getting really excited. All right, if person 3-2 is Lisa, okay, 3-2 is Lisa, what number is Lisa's grandpa? So 1, 1, right? So the 1, 2 is her dad, and grandpa is 1, 1. All right, what number is her brother Bart? So if she's 3-2, okay, remember this is Lisa. Her brother is 3-1. What number is her father Homer? So 2-1 is dad. Oh, somebody just said, I know this family. I've seen them before. Okay, so what number are her two aunts, Patty and Selma?
Oh, 2, 3, and 2, 4.
Yep, 2, 3, and 2, 4 are Patty and Selma.
Wait, how are those?
Hold on. So let's write the answers. Okay, so one question here is which number is Marge then? Mom.
2, 2.
So this is Marge, right? 2-2. She's married to Homer. She's got Bart, Lisa, and Maggie, right? If you guys ever watched The Simpsons. And then Marge has 2 sisters. They're twins, so technically they really should look like this more because that's how you indicate twins. And they don't have their parents up here. I don't know if that's by design because I don't know if did you ever meet Marge's dad and mom? Not really. You just know grandpa, right? All right. Moving on to everyone's very favorite pedigree here. So what we're looking at here is a pedigree for Cleopatra. And Cleopatra is up here at the very top. She's the star of the show. And back in the day, they didn't know much about genetics. And so what they were trying to preserve the royal blood. So you preserve the royal blood by continuing to marry into it. Or not into it, but keep the blood in the family. Because they thought that was important. And so this is a pedigree showing what that looks like. All right, so I know this might seem really gross by today's standards, but let's take a look at what happened here. So we'll start up here at the top. So Cleopatra has 2 husbands or 2 mates, right? That's not that uncommon. So her first son, she has her first marriage, she has a son right here. And then she's married again. This is her second marriage, and they have a son. So she's got 2 sons. They can't marry each other. It doesn't really work out like that. So these 2 darling ladies marry into the family. They meet Cleopatra. She approves. You can marry my sons. And they each have kids. So the first couple has a son. The second couple has a daughter. And then those 2 get married. So who are they to each other? They're cousins, right? So it's not that bad. I mean, they have different moms. They have the same grandma. That's not really that bad, right? They're first cousins, but it's not that bad. Okay, so let's take a look at then what happens next. So this couple, these cousins get married. They have a son and a daughter who then get married.
I'm surprised those babies didn't turn out like
All right, so we have one son born into this family. So he marries outside of the family. This is another darling daughter that maybe great grandma Ptolemy meets. Maybe she's dead by now. I don't know. And they have a son, a daughter, and a son. So their first 2 kids do what? Their first 2 kids get married. And then they have a daughter.
And then they get married to the others.
And then their daughter marries their brother.
That's her brother.
That's, oh, so this couple, so this couple's daughter marries this couple's brother, right? So who are these two to each other? Niece and aunt and uncle, right? And then they have two kids, a son and a daughter, and what happens there? They get married. All right, so then this couple has two children. This girl right here doesn't married, and I'm assuming maybe she died because at this point there's probably some pretty bad inbreeding going on. So usually if somebody doesn't marry, back then it usually meant either they died or they had something wrong that caused them to not be suitable to marry. So one of their daughters gets married to a man from out of the family. That's the first time that happened. Lucky guy. And they have two kids who then get married. Oh, I don't know where King Tut is. Did he marry Cleopatra? Oh. Okay, I don't know where King Tut is. Somebody's asking me about King Tut. All right, how many times then did a brother and a sister get married in this family? Just brother and sister. So there's 1, 2, 3, 4. 4 times. All right, so apparently this family didn't carry a lot of harmful recessive alleles. Otherwise, what we would see, and we're going to talk about this more next week, is we would see a bunch of people being filled in. So when we indicate somebody has a disorder, we fill in their square. And we would probably see like a lot of these people being filled in. If there was a disorder that this family had, it would be really, a lot of them would be filled in. But we'll talk about that more next week. So here is your homework. It is very short. It's just 1 page. So you're going to carry out each of these directions for a point. So you're going to number your generations. You're going to number the individuals. Then there's questions to answer. And you have 2 pedigrees. You have one up here to do stuff to, and then you have some questions down here. So I'd like you to take this time right now to complete this. And at about 11:20, so in 27 minutes, we'll probably say goodbye to our virtual friends and take our in-person students down to see where we would hunker down in the case of an emergency of a tornado. So Mr. Austin, you can hit the stop recording button